Okay, so today what we're going to do is we're going to talk about systems again, but using quadratics. Okay, and what I mean by that is whenever we talk about a system, we have two or more equations that we're working on at the same time. So for example, let's say we have x squared plus y squared is equal to 20. We have a quadratic because we have x squared here, second degree equation. And then we have y is equal to x plus 2, which is a linear equation. So we have a system because we have two equations that we are working on at the same time. Equation 1 is here, equation 2 is here. So let's say we want to solve the system. That means we're trying to find the x and y that fulfills where these two graphs, if we were to graph them, intersect. We're looking for the two intersection points between this item here, which is a circle, is the equation of a circle, and this item right here, which is an equation of a line. Okay? So you have a choice. You can use graphing, you can use elimination, or you can use substitution. I'm going to go ahead and use substitution because this is already set up for substitution. So I'm going to sub in equation 2 into equation 1 because it already says y is equal to. So everywhere that I see y, I'm going to plug in y x plus 2 because y is x plus 2. All right? If I expand this, I get x squared plus 4x plus 4 is equal to 20. Combining like terms, I get 2x squared plus 4x is equal to, actually I'm going to subtract 20 over and get minus 16. And so here I end up with a trinomial, a quadratic again, and I have a choice. I can either solve this by using square roots, or I can solve it by completing the square, or I can see if I have to use the quadratic formula, or let me just try and see if it's factorable, because it might be. So I'm going to see if it's factorable. I know that whatever I have in the front is going to have to multiply to 2x squared, so I'm going to try 2x and x. And then let me try 4 and 4. Let's try plus 4 and minus 4. So 2x squared minus 4x plus 8x is 4x, and negative 4 times positive 4 is negative 16. So it looks like we're good. Factorable, so therefore I can solve for x by setting this piece equal to 0 and this piece equal to 0. And when I do that, I get x is equal to positive 4 divided by 2, which is 2, and x is equal to negative 4. If I plug in these possible x coordinates, I can find the y coordinate. I'm going to plug it into the second equation. If I plug in 2 into here, I get y is equal to 2 plus 2, which is 4. And if I plug in negative 4 into this equation, I get my y coordinate is negative 2. And what that tells me is that this 2, 4 and this are the two intersection points for the system right here. So this line will intersect the circle at these 2 points. So I'm verbally telling you that's one dimension. Algebraically, I just showed you that that's another way of finding the intersection points. And so let me go ahead and just graphically show you, with my fingers crossed, that this works. So let's see if this algebraic trifecta really is true, okay? So I'm going to go ahead and graph, okay? And I'm just going to do a quick sketch, okay? I know that this first equation is going to be a circle that has a radius of root 20, which is between 4 and 5. Okay, 1, 2, 3, 4, 5. It's going to be around here. 1, 2, 3, 4, 5. Around here. And 1, 2, 3, 4, 5. Somewhere around there. Quick sketch, super quick sketch. So if I were to graph the equation of the circle is going to look something like this. Okay? And if I were to graph the equation of this line right here, okay, I know that it has a y-intercept of 2, and it has a rise of 1 and run over 1, a slope of 1. So rise of 1 over 1, okay. So if I were to draw this line in, okay, I should have, at my intersection points, it should be close to 2, 4, and -4, -2. All right?